Hi, this is a project presentation for EEL6825 pattern recognition. My name is Abhishek Jha and we'll go over how to train a neural network which will learn from music. So basically the first problem that we have is how do we train a model which learns from music. So far we have thought that the solution is to build a LSTM based recurrent neural network which will learn from the input dataset. Now we have many different approaches by which we can accomplish this task. So for example, we have the sequence to sequence models, which is a general purpose encoder decoder framework for TensorFlow, which is used for machine translation, text summarization, conversational modeling, and image captioning, and even more. Furthermore, we have generator models, which is a model the conditional probability of the observable x given a target y, while a discriminative model is a model of conditional probability of the target y given an observation x. Also, we have Markov models, which is a stochastic model used to model randomly changing systems. It is assumed that the future states depend only on the current states, not on the events that have occurred before it. This is the Markov property. However, as part of our implementation, we have used the LSTM based neural network. So LSTM networks are a type of recurrent neural networks which are capable to learn in order of dependence in sequence prediction problems. This is a behavior required in complex problem domains like machine translation, speech recognition, and more. LSTMs are a complex area of deep learning. To realize these steps, we have divided this problem into 5 different subproblems. The first problem is to get all the notes and chords from the MIDI files, which is our training data set. After that, we are preparing the sequences which are used by the neural network. Then we are creating our LSTM neural network. Finally, we are training and fitting the model. And after fitting the model, we have a set of output weights which are generated, and we are using those weights to be the input in the same model and generate the output. Next, we'll compare the results at different epoch levels and different loss values. We see that training the 128 cell LSTM network, loss starts with about 48% in the first epoch, and gradually it goes until it reaches 1500 epochs and the loss falls to about 6%, which is a great accuracy. So this is the sequence which is generated after 100 epochs. At this point in time, the loss was 28%, and we can see that here we have some melodies which is created, but however the majority of the part is still learning and it's just trying to play the same notes over and over again. As we increase our epoch size, like we see that after 700 epochs the loss has fallen to about 10%. We observe that the music lines are blurred and we see so many different compositions. Notes are spread out, and which is interesting to see. After 1500 epochs, the loss has fallen further to 6.5%, and we see how we have distributed the notes in a random fashion. So to conclude, the LSTM networks have high performance and generate quality out based on the training samples. We observe as the loss function goes down, the notes generated in the file are spread out and remain the key to create some melodies. In this section, we'll be evaluating our performance of the LSTM network over a period of time. So we'll select 5 different epoch values at different loss rates, and we'll see how the output has been produced. So first we'll be training our last weights improvement. So this is the 1491st epoch, and it has a loss rate of 6%. So first of all, we will use this to predict. And now we'll execute this one. And we see the output has been produced. Now we'll this is the 1500th epoch, and we'll see how it has formed. Oops. Now we're ready to evaluate. So this is epoch 100. At this point in time, the accuracy was about like the loss was about 28.5%. So we'll see how and what this output has produced. And we can see that there's a plenty of nodes to evaluate. It has indeed. Oops, sorry. So this is epoch 700. At this point in time, the accuracy was about 90%, and we can see that it is purely divine, these patterns. And this is an endless supply of music, basically. If we have the right demand channels, we can monetize this in a crazy way.